Hi everyone. Today we will go through November 2015 question 4. Question 4 is related to the organic chemistry, physical properties, and intermolecular forces. This question starts as 4 compounds of comparable molecular mass are used to investigate the effect of functional group on vapor pressure. The results obtained are shown in the table below. Those compounds are A, butane, compound P is propan 2-on, compound C, propan 1-ol, and compound C is ethanoic acid. When we look at these compounds, we can see that compound A ends with ane suffix, so it is an alkane. Compound P is ending with on suffix, so it is a ketone. Compound C is an alcohol because of OL suffix, and D has oic acid suffix, so it is a carboxylic acid. So the first question here is define the term functional group of an organic compound. Yes, a functional group is a certain part of organic compound, and this part determines the physical and chemical properties of an organic compound. What kind of part is that? This part can be an atom. It can be a group of atoms. Or it can be a bond. It can be, so basically an atom, group of atoms, or a bond. In these 3 forms, a functional group can be in the compound. What does this atom, group of atom, or bond do? They determine the physical and chemical properties that determine the properties, let us say, of a group of organic compounds. That is the functional group. 4.2 says, which one of the compounds in the table has the highest boiling point? And the table vapor pressures are given. And we know that the vapor pressure and boiling point are inversely proportional. A substance with a high boiling point have a low vapor pressure. So to find the highest boiling point, we need to look at the table and find the lowest vapor pressure. The compound P has the lowest vapor pressure, so that we say it has the highest boiling point. Refer to the vapor pressures in the table to give a reason for the answer. As a reason, we can say it has the lowest vapor pressure. All right. And the next one, weakest intermolecular forces. When we consider intermolecular forces and boiling point are directly proportional. The stronger the intermolecular force, the higher the boiling point. But remember, boiling point and vapor pressure are inversely proportional. That means the stronger the intermolecular force, the lower the vapor pressure, or on the other side, the weaker the intermolecular force, the higher the vapor pressure. To get the weakest intermolecular force, we need to find the highest boiling point, highest vapor pressure, which is compound A. So the answer is A. It doesn't ask a reason. If it asks, then we could say compound A has the highest vapor pressure. Refer to the table, refer to the type of intermolecular forces to explain the difference between the vapor pressure of A and the vapor pressure of B. We need to refer to the type of intermolecular forces. So let us look at the type of intermolecular forces. Here, the compound A is an alkane and it can form London forces only. But compound B is a ketone and it can form dipole-dipole attraction. So this is the first point. And then what we do, we need to compare the strength of forces. We need to say a dipole-dipole attraction is stronger than London forces. Stronger than London forces. That means it needs more energy to overcome intermolecular forces. Okay, that's it. So compound A forms London force, while compound B forms dipole-dipole forces. And dipole-dipole force is stronger than London force, so that it needs more energy to overcome. That makes compound P have a higher boiling point than compound A, so that compound B has a lower vapor pressure than compound A. That is question 4.3. Now I'm gonna clear all these writings and let me slide this down. So the next question, 4.4. The vapor pressure of compounds C and D are much lower than those of compound A and B. Name the type of intermolecular forces in A and B that is responsible for this difference. Here we said A is a, let me write it here, compound A is a London force. Compound P is a dipole-dipole attraction. What about C and D? C and D forms hydrogen bond. That is the difference. So we say compound A forms London force, compound P forms dipole-dipole attraction. Or you can say A and B do not form hydrogen bond as compound C and D. It's up to you. The 4.5 says, briefly explain the difference in vapor pressure or between compound C and compound D. When we look at compound C and D, compound C has slightly lower vapor pressure than D. That means compound C has a higher boiling point. And this difference comes from the two sides, the presence of two oxygen atoms in the carboxylic acid. So here what we say, compound C and D forms hydrogen bond, but compound C has more sides, or you can say two sides to form more intermolecular forces. As it forms more intermolecular forces, it needs more energy to overcome. so that compound T has a higher boiling point and lower vapor pressure. Okay, that is question 4.5. And the last part of this question is about calculation one and kind of stoichiometry. So let's say during a combustion reaction in a closed container of adjustable volume, 8 cm cube of compound A, 8 cm cube of compound A, C4H10, or namely butane, reacts in excess oxygen. We have excess amount of oxygen according to the following balanced equation. If the initial volume of oxygen in the container was 60 centimeters cube, that is excess, but a value of this excess is provided as 60 cm cube. Calculate the total volume of the gases that are present in the container at the end of the reaction. All the gases in the container are at the same temperature and the same pressure. Here we have the volume. We can go with the Rice table. In Rice table, we usually use the mole number. But in this case, it is difficult to find the mole number because we don't know the exact temperature and pressure. But the good thing is, as all of the substances are at gaseous state, we can use this volume as just like the mole number, because temperature and the pressure same. So we will just use the volume instead of mole number without any conversion. The ratios are 2 for C4H10. This O2 is 13, CO2 is 8, and the water is 10. And then what we do, we write the change. We write the initial. Initial, not the mole number, but volume in cm cube. This one is 8, that O2 is provided as 60. Then we will go with the change in cm cube. And then after that, we will find the end of the reaction, the volume at the end of the reaction. Here we have initially 8 cm cube of C4H10 and 60 cm cube of oxygen. Initially, we don't have any carbon dioxide and water, so I write 0. When reaction starts, all of the C4H10 will be consumed because oxygen is in excess. That means C4H10 is limiting, so all C4H10 must be consumed. Then how much of oxygen is required? To do that, what we do, we multiply 8 by 13, the ratio of O2, and we divide it by its own ratio. So 8 times 13 divided by 2, that will give me 52 cm cube. But here we place a minus sign because it's a reactant and will be consumed. The same way we can use the ratio 8 times 8 divided by 2, that will give us 32. This is a positive value because it is produced. And 8 times 10 divided by 2, that will give us 40 cm cube. At the end of the reaction, no C4H10 will be left over, but 8 cm cube of oxygen will be left over. 60 minus 52 equals to 8. And how much of CO2 produced? 32 cm cube and 40 cm cube of H2O. So at the end of the reaction, the total volume will be 8 cm cube of oxygen, 32 cm cube of CO2, and 40 cm cube of H2O. In total, it's gonna be 80 cm cube. That's the answer for this question. All right, so we are done this question. Thank you so much for listening. We'll see you in another video. Bye-bye.